Hey, it's Mr. Han here. Here are our notes on comparing expression mats. So far we have an idea of what we are allowed to do with expression mats in order to simplify. So right here, before we even get started on these notes, we're going to review a couple of the concepts that we already talked about. So I'm going to ask a question right now. What are some of the things you're allowed to do? What are some of the legal moves that you're allowed to use, okay, in order to simplify? Hopefully you're able to recognize that you're able to flip from opposite land. You're allowed to create zero pairs. And last, you're allowed to remove equal values from both sides. All right, so these are the things we're allowed to do with expression mats when we want to simplify. And once we do all of these things, we should be able to compare which one's greater, the left or the right. Okay, so let's go ahead and take a look. Begin by writing each expression as you see them on the mats. Use the e-tool 2-64. So right here, I'm going to go ahead and just write down what do I see. So on the left, what do I see, right? On the left, I see negative 2x minus, or I'm going to say plus 1 minus 3. And then what do I see in the bottom, right? In order to represent the bottom opposite line, I need to have a negative and parentheses, right? So negative parentheses, and then I have in opposite land, I see negative x plus 3. All right, so that's the starting expression on the left. What do I have on the right? I see 2 minus 3. And then I have this thing called opposite land, so I got to put a minus sign. I'm going to make it thicker so you can see. Minus sign, and then in parentheses, what do you see in opposite land, right? I see positive x minus 2. So right now what we did so far, we took a look, and we wrote down the expressions as we see them, okay? Now, the first thing we're going to do, let me tell you what I want you to be able to do by the end of this lesson. By the end of this lesson, I want you to be able to look at these expressions and simplify. So my goal for you is that you don't have to use the expression mats. Okay, we're going to talk about each step that you're allowed to do and basically take these 3 things up here and talk about what can you do, all right, with the algebraic expressions. So, but because I am still using expression mats, we're going to take a look over here. What can we do on this left side, right? What can we do? First thing we're going to do is we're going to flip from opposite land. So I'm going to take everything I see and take the opposite of. So here, I have a negative x, so I need to make that a positive x. So I'm going to shade it in because positive, there you go. Positive x tiles are shaded in. Here's a positive 1 unit tile. I'm going to make them all negatives by not shading it in. And I'm going to flip them up all to the top. Oh, no. I might need to, oh no, I'm good. Last time I did convert to text and it messed up my iPad. So here I moved them up to the top. I'll put a big old X here, saying they're not there anymore. Let's go ahead and look on the right side. We're going to flip from opposite land. So the opposite of positive x is negative x. I'm not going to shade it in, just leave it like that. And these 2 negatives are going to become positive, and we know that it is positive by shading in. We'll move them up on top. And then put x's here to say they're gone. All right, so what's the first thing we do? We distribute. And now we flip from, the first thing we do, we flip from opposite land. Now I want to show you that when we write an expression, that is the same thing as distributing. So I'm going to put flip in parentheses. So when we flip, remember, what does this portion tell us? Parentheses with a negative sign. Tells us opposite line. So I know that it's going to be the opposite of negative x, and it's going to be the opposite of positive x. So if I wrote this down, it'd be negative 2x plus 1 minus 3. And instead of negative x, I'm going to say plus x. Instead of plus 3, I'm going to put minus 3. So right there, I distributed the negative. I'm going to do the same thing on the right side. Let me move this flip up here. Move this more in the middle. So I have the expression 2 minus 3. But when we flip this, we got the opposite of positive x, which is minus x. And we got the opposite of negative 2, which is plus 2. And if you don't remember, we took the positive x, made it a negative. So this positive x became a negative. And then these negative 2 became positive 2. Okay, so the first thing we could do if we're just looking at this algebraically is to distribute. All right. Next, what would we do? So I'm gonna go ahead and draw all these. I know it's a little bit annoying. If you're not sure exactly what I'm doing, I'm taking everything up here and I'm copying it down here. So I still need to shade this in. So you can see I'm not done, but here's the positive x, negative, 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 negative. I need a couple more negative x's. And then I need 2 more negative units. So there's right there. Just cross-referencing. Right here, right here, right here. These two, and then the x. Okay? So everything is accounted for. I'm also going to copy the right side. If you want, no, I'm not going to do that. So I need to shade these in. This one in, this one in. Negative x. So I still need to shade 2 more of these in. You can see what I did right now is just copy it and move it down here. All right, now what's the next thing I can do? Right, I can create zeros. I'm gonna go ahead and move this over here. Create a 0. Create a 0. Over here, I'm gonna create a 0. Create a 0. Create a 0. And don't forget that's an x. All right, so we'll combine like terms or create zeros, okay? And so that concept here is the same thing as combine like terms. So whenever we create zeros, whenever we create zeros, that's the same concept as combining like terms. So what I'm going to do right here is I'm going to combine like terms. If you remember, combining like terms is when we highlight. Make sure you highlight the sign in front of it. Okay? And then I'll use green. Plus 1, minus 3, minus 3. Let's go ahead, 2 minus 3 plus 2. And then there's a negative x. So let's do the left side first. What's negative 2x plus x? Right, we should get negative x, and plus 1 minus 3 is going to be minus 5. So that's what we have on the left. And on the right, we have negative x. And then we're going to combine these. It's going to be plus 1. It's negative x plus 1 and negative x minus 5. So that's what we got to. And if you look, we have negative x minus 5 here. And then over here we have, so just so you're not confused, I'm on the second row. Negative x minus 5, and over here we have negative x plus 1. You can see negative x plus 1. And that's what we have left on the right. That's what we have remaining on the right. Okay, now that I have this. I'm going to go ahead and duplicate that, move it down. And notice I'm only duplicating the things that are remaining after we created the zeros. Okay, so we have negative x minus 5 and negative x plus 1. The last thing we would do here is remove equal values from both sides. Okay, and so here we would say, what do they both have in common? This can go, and this can go, negative x on both sides, and that's it. That's all they have in common. So that's the same thing as saying, take this out, and take this out. And what's remaining? Negative 5 and positive 1. And we could see that there's negative 5 remaining and negative or positive 1. So we have negative 5 over here and positive 1. Which side is greater? 1 is greater. So I'm going to go ahead and circle this side and say that the right side is greater. Now, none of this is new so far, all right? The only thing I want you to be able to do now is solve algebraically, solve on the right side. So I'm going to give you little, I'm going to give you steps that you can always do. So the first thing you can always do is distribute, right? And that's the same thing as flipping the tiles or taking the opposite land and getting the things out of opposite land. The second thing we can do, we could CLT, which is the same thing as combine like terms. And the last thing we can do is take away equal values. So those are 3 steps that we can always take. Distribute, combine like terms, remove equal values. All right, so we're going to go over a couple of examples and ask the question, which side is greater, using these 3 rules. So I'm going to go ahead and duplicate this. I'm going to take my scissors, cut this out, duplicate so that I can see it. Now, why am I duplicating? So that I can put it next to my work. I'm going to make it a little bit smaller, put it where I can see it while I do the other problems. Okay? So, here, I'm going to be asking you, which side is greater? Now determine which side is greater by just simplifying each expression algebraically, if possible. If it is not possible to tell which side is greater, explain why. Use the E tool if you need to. Now, this is a separate part of the lesson where we're going to only solve algebraically, but I want you to be able to now see, is it possible if we can't determine? Is it possible that we're like, we can't compare these two? And you're going to see what I mean in just a second. But let's go ahead and start here. The first thing we can do is distribute. Okay, so I'm going to go ahead and distribute this negative and take the opposite of. So I have 3x, and the opposite of positive 2 is negative 2, so minus 2, and the opposite of negative x is plus x. So the first step is distribute. Is there anything we could distribute on this side? Do you see opposite land? No. Then I'm just going to copy the problem. Negative 5 plus 4x plus 4. All right, so there's nothing to distribute on the right side. Let's go ahead into the second step, combine like terms. So that's where I'm going to highlight. I'm going to highlight the x's, and I'm going to highlight the units. Same thing here. I'm going to highlight the units and highlight the x's. So when I combine 3x plus x, I get 4x and minus 2. Oh, wow. Look, I forgot to copy that. So I need to still highlight that. Sorry about that. If you are confused by what just happened, I forgot to copy this portion on this line. So that's what I just copied. We'll highlight that green because that's what I copied, highlighted with for the units. So it shouldn't see minus 2, it should be minus 1. 2x minus 1. 4x minus 1. Over on this right side, I'm going to combine 4x. And negative 5 plus 4 is minus 1. Third step, remove equal values. I'm going to remove 4x's from both sides. And I hope you can already see that they're the same, right? 4x minus 1, 4x minus 1, they're the same. So I'm just going to write negative 1, negative 1. They are equal. They are equal. All right, they're equal. Whew, we just did one problem. Let's go ahead and try it again. I'm going to duplicate this so we can see it again. Duplicate this. All right, first thing we need to do, we need to distribute. So I'm going to go ahead and distribute, which is flip from opposite land. I'm going to end up with 2x squared minus 2x plus 6. And instead of negative 3 in opposite land, we're going to say plus 3x. Let's go ahead and look on the right side. Oh, look. We get to flip right away. So negative 3 plus 2x squared. Right, the opposite of positive 3 is negative 3. The opposite of negative 2x squared is positive x squared. And we'll copy the rest of the problem. Plus 5 minus plus 2x. All right. Next step. We're going to combine like terms. So I'm going to go ahead and highlight. Plus 6. Minus 2x and plus 3x. Let's use purple. 2x squared. 2x squared. Plus 2x. And what color did I do? Green. Negative 3 plus 5. All right, let's look on the left side. 2x squared, there's nothing else to combine that with. 2x squared minus 2x plus 3x is plus x plus 6. Let's go ahead and move over to the right. 2x squared plus 2x and 5 minus 3 is plus 2. All right. The last step, remove equal values. So we look on both sides. What do they both have? They both have 2x squared, so we could go ahead and take that out, right? So I'm actually going to subtract 2x squares from both sides. What else can I take away from both sides? They both have an x, right? This side has at least one x, and this side has at least one x. And this has at least 2, and this has at least 2. So I'm taking away equal values, whatever they both share. Okay? 2x squared minus x, those go away. 6 minus 2 is 4. Now on this side, 2x squared goes away. 2x minus 1x is x, and 2 minus 2 is 0. So on one side we have x, and the other side we have 4. Now, the question here is, which side is greater, 4 or x? Now, we don't know what x is, right? X can be any number really, but we don't know. So can I compare a number I don't know with 4? No. So here I'm going to say cannot be determined. I wish I had candy with me. I don't. I would use candy to help explain this problem. But I guess I could try to use something like this, but I'm not going to. If I had, I can't compare 4 with x because we don't know what x is. All right. If we knew what x was, we could be like, oh yeah, one side's greater. So the way we know that it cannot be determined if there's a number of x on one side and then we don't know the number of x's on the other side. So if there's like 2x on this side and then just numbers, we're not ever going to be able to determine when we compare expression mats. Let's go ahead and go to the last one. I'm go ahead and copy this, duplicate. All right. Let's look at this first problem, first side. Can we distribute? Is there anything to combine here? Is there anything to, is there any opposite land? Is there anything to distribute? No, I don't see anything. So I'm gonna go ahead and just copy the problem. -1 plus 6y minus 2 plus 4x minus 2y. Over here, is there anything to distribute? Yes, there is. There's opposite land. So I'm gonna take the opposite of that, plus 2 minus y. Then I'm gonna copy the rest of the problem. X plus 5y plus 3x minus 6. All right, so we went ahead and we distributed or we flipped. Second step is combine like terms. Let's go ahead and highlight all the like terms. Go ahead and do the numbers here. Minus plus 2, minus 6. (4y). Are there any more y's? 4x. Are there any more x's? No. 6y. Are there any more y's? Yes, minus 2y. Let's go back to over here. 5y. Are there any more y's? Yeah, minus y. And x plus 3x. All right. If you need to pause, you can always pause. Let's look on the left side. Let's start with the y's. 6y minus 4y is 6y minus 2y is 4y. There's only 4 x's. Minus 2 minus 1 is minus 3. So I combine like terms on the left side. Let's combine over here. 5y minus y is 4y plus 3x. Oh, there's plus 4x. And then it's -6 plus 2 is -4. All right, last, we're going to take away equal values. So we're going to look, what do they both have? They both have 4y. They both have 4x. So I'm going to subtract both of those. Minus 4x. All right. So I'm going to go ahead and get rid of those. End up with -3 and -4. -3 and -4. Which side's greater? The left side. -3 is greater. The left side is greater. Those are our notes. Good luck.